Alright, welcome to class 2. I'm going to go over this part, which I forgot to start streaming before doing. We are going to make a new folder in our repository that's at the top level, and it's called Students. And inside this folder, everyone should do today, when they're doing their work, they should put the files they're editing in their own folder. So create your own folder inside this students folder. I'll show you how to pull this change. We're going to get this change up. Everyone will pull this change, and then create your own folder inside here when you're doing your work for today. And then everyone will be able to make pull requests, and we'll actually be able to merge all of them, so we'll be able to have all of the work in the same repository. Because this is something that I just kind of realized is that we go on to GitHub here and go to the Hack Upstate code base here, and we see there's 4 pull requests so far. A lot of people are still trying to get all the last steps together, but we can't merge all of these because if we merge one, it's going to conflict maybe with the changes in another. And what happens in Git is, because you don't know which of those changes is the last change for any particular file, and because all Git knows is the lines of the file. So you could have moved things around. One person could move things around, another person could have edited the same thing. So it wouldn't know, like, which do I copy the lines to the lines. All it knows is the lines are here and the lines are here. So if it copies them, it's going to cause errors. It's just going to be broken, maybe. So what it does is it just says there's a merge conflict. It doesn't know how to basically merge together these changes without overlapping changes. And it basically says, in that case, you're going to have to go and fix it yourself. I don't think we want to deal with that and try to merge together the same file for every student. So I think the way we can avoid this is that everyone, for all the rest of the assignments this week, you should commit to a folder that you create with your own name. So what I'm going to do right now is I've just added, so we'll do this again. So I'm in the code base here. Now let's make sure I'm in the right one. Documents, yeah, this is my fork of the code base. So I'm going to add a folder here called Students, and it's at the very top level, so it's not in module anything. The idea will be you should be able to use a folder inside here as your own kind of personal sandbox within your fork here, and then you can submit pull requests back and forth to the main fork, and that should work for the rest of the class. You're free to put whatever folders you want inside your own folder, nest it further. So if you'd like to organize things, you're free to overwrite everything every time if you want, or just edit the same file every time, as long as there's one file. When we get to bigger projects, you might want to have a folder for each project, but right now it's probably just one file. So I just added this folder. I'm going to add a folder for myself, and then inside here I'm going to add a file that's index.js. Actually, no, it'll just be a readme. Hi, this is Gus's student sandbox. Okay, so I've saved this. Now you have to put a file in here. I would recommend putting a readme in, which says basically exactly this. If you don't actually put a file in here, Git is going to say, I don't see any changes, because even though there's a folder on the file system, Git only knows about files, the contents of the files, and where the files are in the file system. So if you just have an empty folder, it's not going to see any changes to commit, because there's nothing actually in that folder. So you're going to have to put a readme or something in here. I would encourage everyone to do this right now in your fork, actually. Actually, no, sorry, don't, wait, sorry. Wait like 10 minutes, and then you can go ahead and do it, or do it later today. But I will try to demonstrate. I will do the folder. I'll commit the folder itself, and then, actually, never mind, double never mind. It's okay to go ahead and do it, I believe. I don't think we'll have a problem. So what I'm going to do here is this. Here's my repository, and I haven't saved. Is this? Oh man, I'm at a different. Okay, I need to stop using my little Git click interface. I'm going to use the console like everybody else, and we're going to switch to the VS Code console. That was a fun little excursion with the terminal. I'm sure everyone loved it, but it's a lot more convenient to just do everything in here. That was just sort of so you get an idea. This is a thing that exists on the computer. It's not some magic part of VS Code. It's just a way to interact with the computer that's by typing, basically. So anyone know the shortcut for the console? Command Control tilde? Nope. You mean real control. Control. Cool. Okay. Nice. And it opens right there. So get status. Cool. So I have untracked students. I'll do git add this, git status again. There's a new file. So it doesn't say anything about the subfolders like I was saying. It just says there's a new file in this students folder that's the readme. So I'm going to say git commit added scause sandbox folder. Okay, committed, and I'm going to push. And then if we, all right, I need to get out of Safari entirely. So I keep going to Safari. Okay. If we go to, I think I can just replace this with my username, and it will go to the right place. Oh, and I don't have any pull requests on mine. So I'm going to do a new pull request. And actually, I already have a pull request. I'm just going to go ahead and merge mine. Actually, we're going to have some fun maybe fixing a couple merge conflicts here. So I think actually here's something I'm going to do. And here's something maybe everyone should do. I'm going to take this here. See how there's two commits. There's the change I made to that index file as a demo last time. And then there's the sandbox folder that I wanted to add. Yep. So this one, I think I'm just going to not do this one. And I hate to say it, but let's learn how to rebase commits in Git right now, everyone. So we're going to do git rebase -I, which means interactive. And in order to, actually, we're going to do git log first. We get a list of commits. And this is the newest one. I added the sandbox folder. If you keep hitting enter, you'll get older and older commits. So this is when I change the index file, include territories and number of states. We keep hitting enter more. This is where I created the file, the original file. So I'm going to copy this. This is the commit. This is like the unique identifier for this commit. This is unique forever, and it refers to this one change, which is the time when it created the day one assignment. I'm going to copy this commit hash, and then I'm going to hit Q, which will quit that git log. Now if I do git rebase -I, paste this thing, it shows this screen. And this shows the 2 commits that came after it. So what I'm basically saying is I want to go back to this way, and I want to sort of edit the history and mess with it, how it works. So it shows you down here there's commands, and you can basically do all kinds of stuff. You can squash things together. You can change the log message. You can use the commit. You can keep it as is. What we want is drop here. So we hopefully will be able to just drop. Whoa, my scrolling up doesn't really work well here. But this one, we probably just want to drop. And then I hit escape. So you hit I to start typing. You type it. You hit escape. You hit colon. You type X, and you hit enter. And if I did this right, we're back at week 6, day 1 assignment. And what happened to my Readme? So the folder is here, and then the commit right after it is the assignment. So the one in the middle is gone. I'm realizing this might be a whole lot to this might be a whole lot to do for people right away. So I think we either need to go around and help everyone do it, or we could make a new repository and figure this stuff out tomorrow because this is going to be a whole lot. A new repo. Yeah, I think we might need to start with branching. Just okay. I think let's just make a whole new repo that's just the student repo. It's just a sandbox. We'll have everyone. Is there a list of accounts we can get with everybody's account in it? We can add them to the repo as contribute. Yeah. Okay. Yeah, and I think so we were trying to sort of add the student work into the repository that was sort of read-only up until now, and a little unwieldy. And I kind of made mistakes, and now undoing mistakes in Git turns out to be very tricky once you're trying to, because of the whole nature of the fact that it's trying to keep track of all the changes. You have to do all kinds of tricks to do that. So anyway, just send your accounts, and I would say just don't worry about doing today's assignment in Git. We'll have it totally figured out tomorrow. We'll have the right place. The sandbox will do tomorrow's and Thursday's assignments in a new sandbox. This one, you can upload. It's going to be one file, so you can just upload it to the classroom or paste the contents wherever. So sorry for that train wreck. Let's go back to the lecture. How about?
I learned a lot.
Yeah. Well, if nothing else, you can learn that nobody is too good to just totally make mistakes. Yeah. Nothing works on the first try. Most things never work at all.
It was helpful. It was helpful. Like when your project didn't work. It was. It was like gave you time.
The good thing was all of your guys' projects worked. It was only mine that
Or just cash business running quicker.
Okay. So the other thing I wanted to do today, just go back to the Visual Studio Code. Just forget about the other folder for now. Go back to Module 4, Week 6, Day 1, you know, you can go ahead because it's your own branch. You kind of can do whatever you want. Let's make a new folder, call it day 2. And inside here, we're going to make an index.js file, just like yesterday. Okay.
Would it be easier for us just to like have a folder that is not so deep inside of other
Yeah,
folders,
that's
just for the sake of like
that's
just
part of
maybe
it,
from the desktop?
so that it doesn't print out. Where are you? It's like, yeah.
I mean, not that we can't find it, but I'm just saying just for the sake of
You can.
simplifying.
I mean, for today, you can feel free to put this folder anywhere. But you just have to be able to navigate to it in code and to be able to navigate to it from the terminal, because we're going to be running Node from the terminal, but not interactively. We're going to run script files and do some demonstrations today.
Yeah, so it might be easier if you guys just create a new folder on your desktop. That way you know where it is, you know where to go.
Okay, I'll do that, and everyone can follow along if you so choose. We forget the repo. The repo's done. It was somewhat of a failure. Okay, so I'm going to say new folder. I'm going to call this JavaScript class. I'm going to call it JavaScript because that's what we're talking about. Good enough. I'm going to go to VS Code. I'm going to say open folder, which is right here. I'm going to go to the desktop here, find the folder called JavaScript, and there is my new project folder. Oh, I called it JavaScript. That's great. I'm going to rename this. Forgot I have this ridiculous desktop. That's the magic 432 hertz healing tone, by the way. That's the logo for it or something. Anyway, it's some, yeah, it's a joke. So again, open folder, go to the folder you made on your desktop or wherever it is, open. You should have an empty workspace here with this welcome page. You can ignore that. If you go over here and you click new file, you can do index.js. And then that gives you a file to play with. And then if you do the control tilde, your terminal now is like so easy to use because you don't have to navigate. Thank you, Dana. That was a very good suggestion. This is much simpler. There's a lot of room to type. So if we do node index.js right now, we can run this file. Now the file is empty, so it doesn't do anything, but we can still run it. Okay. Now if we put something in here, we'll use the nice handy console.log, one fastest thing to type, save it. I'm already in the terminal. You hit up and enter, and we've logged 1.
What
So,
did you just do?
so I,
Okay, we did node index.js.
yes,
And
and
then you said something about
so I edited the file
Okay.
and then saved it,
All right.
and then ran it again. Now you can run your last command by hitting again the up arrow and the enter key. So this is, you can pretty much do your whole project, you know, without typing anything in the console other than up and enter, because you're just retrying it, you know. In this case, it's just one file, and it's just some JavaScript.
Okay, I'm sorry.
Yes.
On my desktop, I opened a folder with nothing in it called JavaScript.
Yes.
And then I pulled that into Visual Code.
Yes.
I made a file called index.js.
Yes.
And now I want to
Go to the console. So you do control and the backtick or the tilde.
But you already got it. So now just run node space index.js.
All right, and then run it.
It looks like you may have created a folder instead.
Oh yeah, you have a folder in the file.
I have to print to see.
And now you have a
They're
folder
yellow.
called
They're
node.js.
light.
Just click off that.
Okay. So, has everyone been able to get this to run index? Okay.
Nope. So that's an internal. So we're just gonna do console.log and then up here the text section.
So, so the top section you're editing
So
the
that's gonna run
file.
code, but we haven't actually typed anything in our file yet. So it's not
Oh, I'm saying no pages. I had a
Oh, you're
screen
right.
in
Console log.
Yep. So if we save that,
Sorry.
so save your file.
No problem.
Now if you run index.jse,
I can probably go about this big, but any bigger is it's gonna get tricky. Okay. So once everyone is got that working, this is all we're gonna need for today because we're just gonna be doing trying a whole lot of things with pure JavaScript and running them exactly like this. So it'll be edit the top part, go down here, hit up, and hit enter. And that's about it. So that's the pattern for today. Let's get right into it. So we're going to talk about JavaScript types. We're going to talk about JavaScript functions. It's actually one of the types is function, but it's a very important one in general. It's very tricky in a lot of ways, and it's used a whole lot. And then just the normal constructs for control flow. This is like the for loop we talked about yesterday and the other kinds of blocks and things that are not functions, but they're stuff that lets you control the flow of the program. Okay, so types. If you remember from yesterday, we had the example. There were two types. They were number and string, or number and text. So I was using the word text because it's like more people kind of understand what text is than what the word string means. It's not a piece of string that you sew with or whatever. It's a string, like a long string together group of characters, which you can read. So generally, you think it might be shorter than a full book, a full text, whatever, but they're about the same thing. Especially in JavaScript, where you don't really have to worry about how long your string is. You can make them insanely long, and modern browsers, they won't even care. So the string can be as long as you want. It's just text. It's just a whole lot of text. You can put books in there. You can, now numbers are the first type we're going to look into in depth here. So this is from yesterday. I was sort of starting var is the old way. Don't do var if you can help it. If you don't know what to do in particular and you don't know that you're going to change something, you don't know you're going to change the value of y here, just use const. So I kind of want to, I would encourage you, everybody, when you are learning this stuff, I would encourage you to type it all out, character for character. And I'm wondering if I shouldn't do that today with that caveat, just because we can do this a little bit faster and with fewer mistakes, because we have quite a few of these. So I'm going to copy this one. I might type the next one, but I'm going to cheat here, copy it. Again, don't do that because you won't get the muscle memory. And if you have the time, just type it out. So copy it over from, these slides, I would say just copy them over into your console or into your file and try running them if you need a refresher on any of this. So we say our index file now has this. We save it. So what we're doing here is we're declaring a variable called x. Not a very good name for a variable, but I don't know what other meaning it has. It's just an example, so it's x. And then another variable called y here. And then we're going to declare a third variable, which is assigned, remember the assignment operator, to the result of adding x plus y. I mean, this just looks like algebra. This one's pretty straightforward. If you log z, you're going to get the value of x plus the value of y, which is going to be 3. Pretty simple. You don't, you know, I think you can do this if you want. I don't recommend it. It doesn't help the readability. I think there's a whole lot of, you know, conversation about like what's the perfect way to format things. Some people, again, don't like semicolons. Some people would put x plus y together but keep the equals. Some people, you know, and it gets really fun when we get to objects and other things. So there's no real agreement, like many things. But this makes sense. This is two constants. You add them together. You assign to a third constant. They're all numbers. So they add. So this plus operator is actually mathematical addition of numbers, and they look like integers because they're whole numbers and they don't have point anything and they're not fractions. That's not true. There's no such thing as an integer number, a whole number versus a decimal number in JavaScript. In JavaScript, all numbers are decimals. All numbers are floating points. You just don't see the other parts. And this leads to some really weird things, and it's sort of a controversial decision. So we're going to run some of these for fun. And I'm actually just going to run these in Node because, you know, we can do them one at a time. So I'm just going to paste right into Node, same thing. It's just you're not doing them all at once in a file. So if we run this, 200.3 times 3, that's 600.9, right? 600.9. If you run it in JavaScript, it says it's 600.9000000000001, which is slightly wrong. And this, if you want to like say, if you were comparing this with another value and said, is the result of my multiplication equals to what I expect, and you happen to pick these two values, they would not be equal, because the computer would be like, that's false. They are not equal, even though it's a tiny, tiny bit off, and you can clearly see it's just kind of a goof. That is not equal. So that can screw up. Like, that's a very tricky thing with JavaScript. It's something you kind of have to remember, that numbers, unless you're you understand well what's going on, don't totally trust that they're like equals is equals, and like that you should treat the numbers as you would real math numbers or pure, you know, imaginary, whatever math numbers that are like perfect or behave without any weird things, because they're not. They're an approximation. Each number really is just sort of a lot of bits which are approximating a decimal number, and there's no way you can store infinite decimal. You know, there could be infinitesimal changes, or you can't store pi because there's too many digits. So everything's an approximation. You really just have to kind of be ready for that to maybe happen. It doesn't happen that often. I wouldn't worry about it. Like, it's not something that like gets you all the time, but it's something to definitely be aware of. Okay. So let's do the second fun number thing. If we divide 1 by 0, this is like, depending on who you ask, you're not allowed to do this. This is undefined. But if you ask JavaScript, it says it's infinity. Yeah, hooray. Like, they have a particular way of interpreting this, which is not like standard. Well, it's correct in some kinds of math, but not like the normal kind. So that's weird. It has the number called infinity. You can say infinity is greater than 5. Well, of course it's greater than 5. It's infinity. So infinity is greater than infinity. No, it's not. You know, there's also a negative infinity. Sorry. If we do this one, divide negative 1 by 0, that's negative infinity, of course. Makes a lot of sense. Okay, so what if we said let's divide 0 by 0? That says NaN. Not a number, yes. So this is probably what 1 over 0 should say. It's like undefined or something. But when, 0 over 0, it's like, okay, that's too much. That's not going to do that. That one is definitely not a number. Now, this shows up in a lot of places, and it might show up if you see unexpectedly in your program a bunch of nans run, it means that you've added something or you've done math with something that you can't do math with. And JavaScript has flipped out and said, this one's not a number. And then it sort of propagates from there. So if you say not a number plus 5, well, that's also not a number. So that, as soon as something is not a number, then anything you combine it with math operators is also going to be not a number. So these are two kind of weird numbers in addition to all the decimal stuff. Numbers are not like, whole numbers, and they're not conventional. JavaScript is very quirky in the sense, but now this stuff is so mainstream that it's like everybody's used to it for some reason. So you got to get used to it. That's the lesson, I guess. Okay, that's numbers. Strings. Strings we talked about. They are text. They're just a bunch of characters together in a row. You can wrap them in single quotes like this. You can wrap them in double quotes. It will allow you to do either one, but they have to match. So you can't do a single quote and a double quote. And like if you want to put a like a apostrophe. Oh man, it's making, see, Dana, look at this one. If you do apostrophe in this, it makes a slanty fancy apostrophe. That's gonna mess it up. And you can undo. So I want a regular. So if I wanted to say somebody's with an apostrophe in it, you can't really do that because, well, that it's going to think, oh, that's the end of the string. But then there's more. That's just part of the string. So in order to do anything like this, where you want to say, no, this is a string, you use an escape, what's called an escape. So you put a backslash in there. And in VS Code, that should turn a different color, actually, to show you that it's calling out that it's, something different. Let's go to VS Code. So see, this one gets a little lighter highlight because it's like, this one's an escape character. It doesn't actually look like this. It's just when you're typing your code, you need a way to represent an actual literal apostrophe, and you've already used the apostrophes to wrap your string. So you need to do something special there. Okay, let's copy that whole example in and get rid of the weird grammar, I guess. So if you have constant x is hello, constant y is the string space, and then world. So the space is part of this one. And then you add them together where you use the plus operator. This time the plus operator is going to concatenate the two strings together. It's going to basically just print or store one and then the other right next to each other. So I will quit this here and then we'll run it again. I didn't save it, so it's not going to run that. We'll do it. Try it again. Okay, so it logs what you'd think. This, all of this, and then all of this all together. Now, this is just sort of a little reminder here, but let's say I made y1. What's it going to say? It's going to say hello 1 because it says, oh, I can make this into a string. And it decides to just make it into a string because that'll work, right? Now, if we do the reverse, we say 1 is x and y is hello, and we try to run that, it's going to say, well, this is I'm expecting some addition here because this is a number, and I can't make hello into a number. That's definitely not like you can't convert that into a number. Okay, never mind. It totally did. It totally said, oh, the second one's a string this time, and I can convert this one to a string. So it tries it both ways. I didn't realize that. There's a way to like totally freak it out though and make it just say, never mind, not a number. And there's actually a whole talk on that. I think I'll make that one of the extra credits tomorrow about just a bunch of weird things. Like if you do, this is an array plus an object, you'll get some strange things. Let's not get crazy here. Anyway, if it can convert this kind of tricky type coercion, it seems to be working okay for me, and I can't break it. But there are ways it'll break, and they will surprise you, and you won't have a fun time tracking down those bugs. So watch out for the fact that this works on both strings and numbers, and that it does these weird rules to determine what the result is going to be. It could be a string or a number, depending on the rules. Okay. So here's another thing you can do with strings. We have a string here that's the word world in quotes, and we're calling this is the place. This is the name of our variable is the place. The value is the word world. You can do a string, you can combine strings together without the plus operator, and this is actually something that is often very much preferred if you have the tools or the browser to support it. Chrome will do this, Firefox, I think like most of the the non-Internet Explorer browsers will do this. And if you do something like React, it'll have a tool to like compile it for all the other ones anyway. So a lot of, we use this kind of thing a lot instead of plus. And one of the reasons is you can make place a single word, and you can make hello a single word and whatever, and you don't have to like stick together an extra space in the middle. You don't have to say like word 1 plus space plus word 2 plus another space. You can just what's called interpolate. You can say, I want to make a special string. This one is wrapped in backticks. This is another way. So this is the character under the tilde up in the corner. This is a third way actually to have boundaries for a string. So you have single quotes, double quotes, and backticks are all okay for strings. But backticks are special and have this extra feature where if you put this special pattern inside the backticks, you do a $sign and then a little group in brackets here, this turns back into a JavaScript expression, and you can put whatever you want in here. So we can say we want to put our variable place in here, and notice we've already got the space. We're all good to go. If we run this, we should see, if I save it and then we run it, we'll see the same hello world. Now this can be an expression. This can be 1 plus 1. So we can say hello 2 because it's going to evaluate that expression, because that's back to JavaScript, and then take the value that the expression becomes, and that value then is interpolated into the string. So all of that collapses in, and then it goes right in, and the $sign and the brackets themselves are gone from the result because they're just used to note that you want to interpolate some little piece of code, an expression really. So when we talked about expressions yesterday, this can be any expression. This can be very long, or it can have a lot of parts or whatever, but it has to evaluate to some value.
I didn't get that though. I just got the low $sign.
Did you use the backticks? So those are single quotes. This one is slanted.
Oh, I see. Oh,
Okay, so like I guess I just want to say, like, this is you don't need to memorize every single thing we're going through today. We're going through a tour of all of this stuff. You're probably going to use it. You're going to want to know about it. You're going to want to be aware of it. I forget how to do this stuff all the time, and I'm always looking on the internet. What's the best? How does the interpolation work or whatever? Like, don't worry about like this is not normal for people to just like memorize every single part. Now, when Ryan comes and does his, he might know everything about Git and everything about strings and everything because he's got a very good memory. But that's not like common. That's not expected or anything, So don't worry about that. Anyway, let's continue the tour. So these are strings. Strings are for words, and they have. This one is very nice. I would definitely use this one. Okay. Next type is a Boolean. Does anybody have kind of some understanding or familiarity with what a Boolean is? It's basically.
I'm trying to remember.
Okay. It's logic. Yeah. So it's the same. Exactly. It's the same as binary. Um, Functionally, it has two possible values, and it maps directly. If you wanted to, you can map it directly to a switch in the actual computer that's either on or off. So you use the word true, all lowercase here, and the word false, also lowercase, as these are keywords and they are Boolean values. So there's only two possible values. This operator is the Boolean AND, or just the and this basically says the result of this expression is only true if both sides of the AND are themselves true. So this one is going to be false because one of them is false. So this and this are not true. One of them is not, basically. Now I've used a let here on the z because we want to sort of make it mutable, because let's try the opposite one down here. Let's change z to be x or y. This one is the or. This one returns true or evaluates to true only if, actually, this one evaluates to true if either one is true or if both of them are true. So if any of those two is true, then the z will be true here. So we're going to see false and true. This one's pretty predictable. I have to do it anyway, so there's no mistrust or anything. I'm not fooling you. False, true. All right, and we've reused z here. We wanted to change z to be, a different operation. The result of that, so it is mutable. Let. Okay. The next stuff. Oh, I kind of left out of here. There's a whole thing in JavaScript about falsy and truthy. Falsy. So there are these actual keywords, true and false. But remember how when you're talking about if you do a hello, the string hello plus the number 1, it's going to say, oh, I can convert that to a number. Well, JavaScript will do that with anything if you want to do an and. If you say something and something else, it'll be like, I can convert anything to a true or false. And it has some weird rules for doing that. So in order to in order to use this nicely, you'll see it used on things which are not true and false sometimes because people know what those rules are, but it can be very tricky because some things that you think might be false are actually true when it's coerced to what this operator knows about. Now we'll do a little bit after the types. So that these are the types. Anything else is not that type, but it will be coerced to this type when you use these things, and it's tricky. So something there. Okay, so these two are special values, and there's a lot of people say there shouldn't be two, there really should just be one, and it's kind of silly that there are two. They're two different things. One of them means no value, and one of them means the absence of a value. I mean, why are they different? Now, they're usually not significantly different, but if you look at this, I realize we haven't done the double equals yet. So the double equals is another operator which says, is the thing on the left the same as the thing on the right? If it's the same, this will evaluate to true. If it's not the same, it will evaluate to false. So that's true, but in JavaScript, the double equals will first try to coerce. It will do the thing that we're doing when we're adding a string to a number, and it'll say, is there any way I can convert something on this side according to this weird set of rules so that they are equal? And if it can, then it'll say that's true. If it can't, it'll say it's false. That is really tricky, and it's so tricky actually that most people will say never, don't even use the double equals. You always want to use the triple equals, because the triple equals doesn't do that. The triple equals says if they're not the same type, forget about coercing them. They are not the same. That makes a lot more sense. It's a lot more consistent. It's unfortunate that it's like an extra equals everywhere and you can forget it. But like this one, I think I should just delete it. But I'll demonstrate it first. That we have null and we have undefined. They're weirdly different. If you do the double equals, it'll say I want one of these to be the same type as the other. It'll succeed and find a way so that they both evaluate to a comparative value in some type, in some strange rules of the type system. So the first one will print true, but if you do triple equals, it'll say, wait, they're actually different types. They're not the same, and it'll print false. And this is actually one of the only times when you might want them to be true and use the double equals, but I think in general it would be good to say just never use double equals. I'm going to put in the slides right now, I will copy the comment style. So this will say, don't use double equals, use triple equals. And if you want to know why, run the code and that shows you why. Okay. I think we need to have a little section on some of the operators that you might not be familiar with, because I think I forgot that we didn't really do all the rest of the operators. So I'm gonna make a cheat sheet for operators for today, but let's just try a couple in Node so that you can see them. We have the plus, which adds numbers. It concatenates strings. You get it. Minus is minus. I mean, these ones are pretty easy. These are math. If you try to do a string minus 1, that one, I've got it. That one's not a number, because it's like minus doesn't make any sense for strings. Like you can't subtract a string from another string. You can stick them together, which is sort of, that doesn't make sense for plus really equal either, but they're like, okay, that's similar enough, I guess. It's sort of like adding. You can't minus a string from another string in any sort of intuitive way. So there is no, it's not defined for that. And so it says, well, we're going to have to do this operation on two numbers. And then it says, well, this one, there's no way this can be a number. So whatever the result of that is definitely not a number. That's why we get the not a number. Times is probably similar. Let's see. times 5. That's also not a number. You can't times a string by 5. I think in Python you can, and it'll just print it 5 times. It'll be like, that kind of makes sense, you know, print it 5 times. But in JavaScript, it's like, no, you can't multiply a string, so that's not valid. But, you know, obviously 5 times 5 is valid. I don't know what this will do. Not a number. So it like says both of these got to be numbers because we're trying to multiply, and neither one is, so it's definitely not a number. Sure. Division works as you'd expect. It's the slash. And if you do, obviously, 5 divided by, whoops, complete the string. If you do 5 divided by a string, that's definitely not a number. So those are your normal arithmetic operators. There is, to do powers and other things, there's no simple symbol for that, so you have to do math dot something. I think it's POW. And then it's a function. We'll get to functions in a little bit. So you would run it like this, and this is 4 to the power of 5. And that's, so all the other math stuff, square root and all that math stuff is inside functions that are on this special math thing. So those are, so there's no other real arithmetic symbols except maybe the caret for power of. That doesn't make sense. I'm not sure what that just did. I think that's a bitwise operation. That's some real weird logical stuff. So let's not worry about the bitwise ones because those are extremely confusing and will not help. And you don't really use the bitwise ones, so don't worry about it much. Okay, so those are some operators. The double equals, whoops. This is another Boolean operator, sort of. So obviously this will not work. But if you do true equals equals 1, that's also going to say true. This is why this one's very problematic, because of this type coercion. The double one says all kinds of weird rules. Because 1 is not 0, it's like, well, that's sort of truthy. And it sort of would be if you're doing binary, you know, if you're doing binary numbers with the actual values 1 and 0, you could do that. So it sort of has to be, but like -1 is not true, and anything negative, yeah, but like but 5, yeah. Let me see here. Yeah, that's super weird. It won't coerce a negative number. So they're all inconsistent. They're super weird. They were thrown together in like a week. JavaScript famously was built in like a week. So there's a lot of weird stuff here. Just don't use that double equals. It's going to do some strange things. If you do the triple one, everything's a lot more predictable. You can say true triple equals 5, and that's definitely false. They are not the same. You could say true triple equals 0, triple equals false, triple equals true. Well, that one is true. Okay, so this one, this operator, the triple equals, is much more predictable, and so this is the way you'd want to normally compare whether two things are the same. The opposite of this is, we saw the not operator yesterday, the exclamation. So if you do not true, you get false. If you do not true, which is what I did earlier, you get true, because it's twice, it flips twice, back to the original value. This not is a way to check the truthiness of anything in JavaScript. If you want to see like what is JavaScript going to consider this random thing when it tries to force it to be true or false, you can say not, because the first not forces it to say this is like a true or false, and then the second not flips it back to what it originally was before you knotted it. So this is a way to say anything. You can say 6 is truthy. Okay, 0 is falsy. The empty array is truthy. You know, the empty object is truthy. Function, keyword, that doesn't even make sense. It doesn't like that. Okay, anyway, that is the not operator. There is a corresponding to the triple equals. If the triple equals is basically saying, are these two things equivalent and strictly equivalent, not with any of that weird type stuff. To do the opposite, you would do the not symbol and then 2 more equals. You can do the not symbol and 1 more equal, but that has the same problem as that double equals with all the crazy stuff. So do the not symbol and 2 more equals. Again, I'll put all of this in a cheat sheet, so no need to memorize it. But this is, you know, how you check that things are not equal. 5 is not equal to 4. That's true. 5 is not equal to 5. That's false, because it is equal to 5. So these are more logical operators, and that's what we're showing here. And I think that's all I have for today on the rest of the operators. But like, definitely if you run into something that's weird, there's a couple different weirder ones. There's a modulo, which is like some kind of strange division, circular division process, which is useful for finding the remainder. It's very similar to the remainder, but it's not exactly. It's like the remainder from division. There's a couple other tricky operators, and then there's bitwise. You probably won't need to use those hardly ever. Again, you know, I'll make a sheet with all the ones and then the tricky ones at the bottom. And definitely like reach out if you're wondering why something does a certain thing, or like what it is, or of course. Okay, so back to the rest of the types. Null and undefined. Those ones are both falsy. They're very weird. This one's fun. So the next type is object. And objects are very widely used in JavaScript. And they're a very powerful technique in JavaScript, because you can make them as big as you want. You can put as many layers deep. You can put objects inside of objects inside of objects, and like you can create a whole hierarchy of data. You can create a whole library with indexes complete and everything that's inside of one object. And they're very, very easy to use, because JavaScript is happy to just say, here's your computer resources. You don't need to worry about where is all this data going to come from or be stored. You just add things to the object, add objects to the object, and you can do a whole lot. Okay, so let's try this example. Can anyone figure out why this one is wrong? What's going to break about this one, just from looking at this? So we have X with these keys, Y with these keys. We're adding X.A plus Y plus dot B, saving it in Z, and then logging that. Right. Y doesn't have a B. So it's going to happily say, oh, there is no B for Y, but you know what that means? That means B is undefined in Y, right? So Y does not have B defined. So the value of this, because there's no B, is going to be undefined. The value of this, the dot here, is it's the way to look up a property in an object. So you say, I have this object X, I've just defined it up here. The curly braces mean object, so that's what this is. And I want to look into this object, and I want to return. So the result of this expression using this operator is going to be returning the inner part of X, the value that is referred to by this a. So x dot a is 1, x dot b is 2, y dot c is 3, y dot d is 4, and anything dot anything else is going to be undefined, or x or y dot anything else will be undefined. So when we try to add these, we're probably going to see, I'd say not a number. Oh, I gotta save it. Yeah, so it's going to try to add undefined to 1, or 1 plus undefined. That's definitely not a number. It doesn't know what else to do with the plus, so that's not a number. If we change this to y dot c, well, y does have a c. The value of that is 3. So if we add these two together, a and c, or xa and yc, we're going to get 4. No, I should probably save it, and then we'll get 4. Okay. So that's sort of the general idea of an object. You can just declare them to have whatever you want. You can declare them to have many levels. So we could say this is y, it has c, it has d, and then it has e. And e is another object, and this has red, and this has green, and this has blue, and blue is an array with 1, 2, 3, and this structure doesn't make any sense. There's no reason you'd ever make an object looking like this, and if you did, somebody else who was working on it would get very mad at you because they'd look at it and they'd say, what were you thinking? Why is this so confusing? But the point is that you can just make this object and declare these things to be nested anywhere you want and to be referred by keys as deeply as you want. And then, like, if you wanted to say, instead of xa plus yc, we could say x dot a plus y dot e dot blue array. So this is how you get to the array 1. Now array indexes, this won't be the 1 here. This will be the index 1. So the indexes start at 0. So blue y dot e dot blue dot 1 is the second item in the array, which is going to be the 2. So we're going to get 3 out of this. Now you could say dot green, and that's going to try to add true with 1, and probably be not a number. No, true adds with 1, and the value of true is 1 when you try to add it with 1. That's great. This is, objects can go deep. You can go 100 layers deep if you want, as long as you have the memory to do it, and it makes sense. I think more importantly, it's like what structure of the object is going to make sense for what you're actually trying to do. Is it easy to find the things you need? Are they named well? Are they in good types? And then you can do whatever you want, and the engine will happily just give you the memory space or whatever it needs to make all that stuff. Now, the one other thing about an object is the keys normally have to be alphanumeric, and they can't start with a number. So you can't have a key that's like 5 style. That won't work. It's like that's a number. That doesn't work. You could make a key that is a string that has anything. So you can say whatever you want. And this will work the same way, but you're not going to be able to use the dot to refer to this one. The dot is a convenient thing if the names are nice, just letters, and they're just words. But if you have a whole bunch of characters as the key that are weird and have meanings in JavaScript, you can't put them right in your code, or else it's the syntax. It's not going to be able to understand what is, part of the object and what is not. So the only things that are allowed when you're using this dot notation are letters and then numbers after the first letter. In either case, upper or lowercase. But you could still do this key. This could still be an object key. So you could say y dot this, and you don't do dot. You do the same you would do for an array. You do brackets, and you just put in that same string. So this one is going to be 2, I think. Okay, there is no reason anyone would ever do this. There's hardly ever a reason to make a key that can't use a dot. So you'll almost always want to use dots. They're very nice, and yeah. But sometimes you really do. You're like, man, I wish I could have an index here where I got some value from a web URL maybe or something, and that key referred to some other object or something. And if it's anything like that where it's not just letters and numbers, then you need to use not the dot. You need to use this thing.
When do you use object, like what is that connected to, like in real life? Like under what circumstances do you use object?
Like let's say you had what for the project you're working on, it's not Netflix. Which one is it?
The capstone one?
Yeah, either the capstone or the last project. Okay, so an object could represent all the data in that project for a job. You could have an object that says where the data is time and price and level of service or type of service, and all of these things would be listed here. You could have part of that object could then be nested further and have other things. Now we're going to get into, when we get into SQL and databases, there's a very tricky thing about nesting data in all-in objects and storing it like that versus flattening the data and then having relationships between it. And when you do database kind of stuff, you start to think, well, nesting it when you're storing it might not be good. But when you're on the front end and when you want to download that and when you want to work with it nicely and when you want to keep it all in the same place and keep track of it, then you might want to have an object which has all of this data that's related to the job and then a nested version of the employee and then a nested version of the customer as well, and all kinds of other stuff could be lumped together for the purposes of using it on the front end. So that's one example. Here's another. Let's just look at another quick example. I think this still exists. This is a Star Wars API. So you can request any of the data about Star Wars, I guess, from here. And like the people is one of the, so this is an API, we'll get into this later. And this is JSON, but this JSON means JavaScript object notation. So this is intended to be converted directly into a JavaScript object. And like you can see, this is Luke Skywalker, there's a height, there's a mass, hair color, etc. So all of these, the data that's associated with one object, or logical object, is then able to be put in the same thing. And if you copy this out of here, and we go to Visual Studio Code, and we said var is bad, const person equals this. And we just paste this whole big chunk. We could say console.log person.name. And because name doesn't have any weird characters in its letters, it doesn't matter that the key here has quotes. The quotes are necessary for some purposes, but we don't need to do the quotes down here or the square brackets. We can do the dot because it's just the letter's name. So if we log this, we will get nothing. Cool. So we get Luke Skywalker. So that's that's some real data, I guess. Real. Okay. So that's objects.
So what do you use that site for? Like if you,
Mostly for like educational stuff like that. Like if you wanted to make an app which lets you browse around different Star Wars
no,
stuff,
but yeah, okay, so,
you can use their site, and it's pretty much read only. But you know, it's public. It's just for public domain for anybody to use. You can make a library or a database or a little an interface that goes on top of it. And if anyone wants to sort of not have to build all the back end stuff so much for their capstone or start without having to build the back end stuff, there's more than just there's a lot of different APIs, not just that's one of the older ones. There's a lot though. There's some really cool ones that are not like video games or movies or whatever, but and I'll try to find a list of those because they're actually very nice. They can let you focus on some of the front end stuff and just work in a kind of abstract on some problem that's just totally abstract. Okay, so that B, sorry, these slides are just like the B was wrong. We had to put the C there, and this highlights that you can use this square bracket as the same way you can use the dot. So word up here is referenced by this square bracket and the string in the square bracket. This one is an array. So arrays are square brackets, and they don't have keys. Like the things in the array don't have the names. So in X, we say everything in X has a key and a value. The key here is word, and the word is good night. In an array, none of the things have names or keys. There's just a list of values. So the values are moon, stars. And I'm just showing again, you can do either kind of quote. Oh, I don't want the weird quote. You can do any kind of quote you want as long as they're the same. And you can reference this like the array index would be, but instead of a number in there to say the first position in the array, you're using the key to say the key of the object. And they're actually very similar under the hood. An array is very much like an object which has numbers for keys. So if we do this, we are going to see word is good night, we're going to see a space, and we're going to see moon. Sorry. Save it. So we see good night moon. Okay, I think we have symbols. Symbols are like a unique, they're just some variable, some value that's unique. That's all a symbol is. I never use them. They're a type, they're in the list of types. You might use them. All it means is it's unique. You can give them a name, and then the value of this is a unique symbol, which will not be equal to anything else. That's the whole idea. Not much of a use for them in normal projects. And then function. All right, we will get to function.
Can you go back to the array thing?
Sure.
So the first one is an object.
This one is an object, yes.
And you can call it, you don't have to have the squiggly braces to call it?
This is here as a squiggly brace. But when you're like looking into the object, you never use the squiggly brace. The squiggly brace is only to denote, to declare a value, which is an object value, which then we're going to assign again to the variable here. So the curly brace really means this is a literal object value, which I'm typing out into code. And it's not used for other purposes. This here could be dot word just as easily because it's an object. And this could be in quotes. It doesn't have to be, but it could be. That's all that's illustrating. Arrays. So the task for tonight. There's another chapter, and then the thing that the activity should be is a video to follow along, and it's called Array Cardio. So it's like you're gonna get some fun just stuff with arrays. I would just go with it, try it out, try the examples. You can do a lot of stuff with arrays, and you're gonna be doing a lot of stuff with arrays all the time, pretty much your whole professional life, because they're very useful, and lists of things are very useful, and you can do a lot of very cool transformations on arrays and manipulations, and use them to do very useful things. So yes, array technically is not. So remember from yesterday we did the type of operator. So that lets you look at the type. So we can go here and say, here's my array. It's an array with 1, 2, 3 in it. Type of X is object. So it's like JavaScript is like arrays don't even exist. They technically do, because you can do things with an array that you can't do with an object. So there's like, but this is sort of the most basic primitive understanding that JavaScript has of these types, and it says they're similar enough where this is an object. It shouldn't be. It really shouldn't be. But just know, yeah, if it's square brackets, it's definitely an array. And I think there's better ways to test, like, oh, no. So if we do, so this has a map function because it's an array. If we do an object, oops, let's just do any old object. It could be an empty object. Map is not defined on an object, but it is defined on an array. So they're totally different, and there's ways to test, and you can check different things. Like one of them is not x.map. That's true. Not y.map. That's false. They're different. But it's very silly and confusing. Unfortunately, this is one of those things that I clearly just forgot a lot of that. You're going to forget it. You're going to get confused by it. It's par for the course, because JavaScript is, it's very good at a lot of other things. It's ubiquitous, and it runs on every possible computer pretty much. That's why it's still worth doing, and that's why so many people still do it. It's because it has what are called good parts. There's a whole book, a classic book written called JavaScript: The Good Parts, and that was like a big statement back then, because the implied thing was that all the rest of it are bad parts. It has quite a few bad parts. Anyway.
I can't understand why they've never. I was reading in the book that you assigned us.
Yeah.
About how they were going to improve it, and there was big controversy, so they didn't.
Mm-hmm.
Later they did. Why don't they just fix it?
Well, so fixing a lot of the things would break a lot of older websites. That's really the reason why. It's because there's so much of a inertia, and there's so much established things that have worked for many, many years. And if the web committee people said, okay, we've decided that all browsers will now change, and some people are going to get very unlucky. They're going to have to rewrite their whole websites, and they might never be able to rebuild them. That would never work. Like, people would never go for that. So that's pretty much why it's never happened. It's been a very, they have a very tough job trying to, sort of improve things and make things good and give people guidance. when there's sort of a long history of weird choices and things that people didn't work out. C++ is very similar in that way. It's like it has a long history. It has like 6 different versions that all look different, and like every time I'm like looking at it, the people who are showing me it are like, oh, that's the last version. There's a new version now, and everything is different, you know. And it's not common. It's like I don't like it because it's way worse than this actually. But that's another one where it's like it has, you know, there's a history to it, and there's a yeah. Okay, I think we should break. Yeah. So. Welcome back, Internet people. Here is, yeah, anyway, I was just saying today is a lot of fundamentals in a sense, and very sort of, it's a sort of a tour through a whole bunch of different things. It's probably a little bit overwhelming. I had to look up a lot of this stuff, so it's not like, but it's gonna, it's gonna start clicking once we get into things, and in a little bit. So we're gonna do, I think, 2 more things: a little bit on functions and a little bit on if statements. And then with all of that stuff, we're gonna try to make a little parser for a little programming language. So we're gonna make a very simple programming language, not Turing complete or anything, and we're gonna actually parse it and evaluate it inside JavaScript with JavaScript.
And
It's like
parsing is what?
parsing is reading a string or a program and then deconstructing it into the pieces that are the functional parts of the program, like operators, like variables, keywords, all of the parts we looked at. And it's very simple. It's just a calculator, but we're going to build something that takes a calculator input and does all the math operations without it being JavaScript. It'll be calculator script inside JavaScript. So programming language inception, in a sense. It'll make it will make more sense once we get to it. It's pretty cool. But we need to do a couple more things. The last type on our list of types here is function. It's not fair that object and array are not different. They're totally array deserves a type, but technically it's not in the list, so that's why it's not there. Anyway, the last one is function.
Are you streaming?
Yes, thank you for the. I think so. Anyone post in the channel if I'm not. Yeah. Okay, so function is just a sort of like a little program. It's a sub-program. It's something that is a piece that you want to run usually more than once or from different contexts. You want to be able to reuse it, or you want to just separate it so that it's easy to understand one part of your program and give that part of your program itself a name. So a function is very similar to a variable. You're naming something that represents a value, but a function actually does something. And that's why it's going to be much more, you're going to spend a whole lot more time thinking and kind of learning what functions are and how they actually work than you would for decimals or numbers or strings or whatever. So we're going to just start today with some pretty simple stuff. You do a function with, you declare a function in the same way you can declare a variable by using this keyword called function. And we're going to declare a function here. The function is called increment. The part in here is the arguments to the function. So we're going to say, here's our function. This is some stuff that I want to happen. Anytime I say increment, I want this stuff to happen. And in order to make it be able to do something that's useful and not the same thing every time, basically, we want to be able to tell it some things every time we run it. So in these parentheses here, we name some variables. You can put as many as you want. And you can name them whatever you want. Name. Right now it's x, because these are abstract examples. But this function is going to take an argument here, and then every time you call it, it's going to return that argument plus 1. So we can use this as often as we want, and every time we do it, we're going to get back. So z is going to be assigned to the expression which evaluates by running this function on this input, becomes the x goes here, 1 gets added to the x, we return this, that becomes the value of running this. When you run this function, the return value is what it turns into, is what it becomes or what you get out of it. And then that is going to be assigned to z. So if we run increment, which adds 1 to on the number 5, and we set it to z, and then we log z, what do we see?
6.
Bingo. That's that's a bingo. Now, and if it's named well, if somebody has named their functions well, sometimes you shouldn't even have to look at what it's doing. You should say, well, that's named increment, and the word increment means to tick up by 1. So that's what it should do. We're going to increment 5, we'll get 6. And indeed, when we figure out how to run it, we get 6. So, there's 2 kinds of different ways, actually 3 now, and they are right here. So you can declare a function by just saying function this. A function, though, itself is also has a name and is a variable. So you can assign a function with the same assignment operator. And this one, so this here is not declaring. This is like just making an anonymous, it's called an anonymous function. It's just poof, a function out of thin air because you have described it. In the same way, when you put the curly braces by themselves and in the right place, that's an object. You're saying if object, in this case, you're saying a function exists right here. And you're going to assign this to the variable increment. This has basically the same result. There's some subtle differences. So I used to use this one a lot because it was like cool or something, and then now everybody uses this that I work with, so I use this one. This third one, though, I also use this a lot. This is a little bit different. It's much more modern. This is saying the same exact thing. It's much more compact, but we're saying the arguments go on the left of this special arrow thing. They added a special arrow to the language. The arguments go on the left, and then the rest of the function goes after it. And if the function is just one statement that returns something, you can leave out the return, and you can put it all on the same line and leave out the brackets and everything. So you can actually define a function in just that number of characters. And this becomes actually pretty useful if you are, once you start getting into using functions a lot for a lot of different things. And this, I think for the next many, many weeks, we're going to be using them more and more, and you'll see them come up in more and more places because they're very useful for a whole lot of things. And in the case where you want a very small, quick throwaway function just to do a small little operation in one place and then just forget about it, that's when this kind of thing is going to be really nice. In this case, we're assigning it to increment 2. So after all of these, if we run increment 5, we're going to get 6. They're all equivalent. The other thing about the arrow is a thing about scoping, and I think maybe let's get into that another day or do in a later, because scoping is kind of weird. There's a this in JavaScript and functions, and it's kind of obscure. It's not so often used. It's like kind of one of those voodoo things, which is kind of going out of favor because it's a little too weird but it exists, and this function has a different this in air quotes for the internet people, as the rest of the functions have a this. It's a different scope. Other than that, they are the same. It's just a shortened version. Now, here's some weird things you can do with functions. So you can log this. You can console.log x, a function that takes an x and returns that x plus 1. And if we do that, we're going to see just this word function. It doesn't do it. It doesn't return anything. It's not going to know what to return because we haven't run it yet and we haven't given it an x. Now if we did this, put the whole thing in parentheses, right? Here's our x, take an x, return the x plus 1. This whole thing is a little mini function. And then we run it right away with the 7 by putting some parentheses at the end, just like we run increment or anything else. We're going to get 8. So it doesn't care that this hasn't been defined anywhere. You can just say, there should be a function right here which does this. Oh, and by the way, you're going to run it right away and then forget about it. And the interpreter is fine with that. It lets you just say, this is a function expression. This expression evaluates to a function. Now run that function. That whole thing is an expression. And now it all collapses down to one value. This is totally fine. It's a little bit mind-bending just to see like this. And it's something that like is kind of tricky in a way, because you're not gonna be entirely sure whether something has run or not run sometimes, and you'll get them tripped up. You know, this is a sort of a pitfall of this, but it can be very useful in other places. Nobody really does this exactly, but passing a function like this or running a function immediately is a pretty common thing to see. So this is another way of writing the same thing. You put parentheses, you have a anonymous function which you just poof into existence right here. This is an expression which is a function. This runs the function, same as writing, you know, increment 5 if increment existed. But it's like this function 5, right? And this works fine. Works the same way. And this is the same. I don't know why it is the same time. Whatever. So these are immediately invoked function expressions. Very confusing name, but if you read it very carefully, one word at a time, that's exactly what it is. It's immediately run or invoked. It is a function, but that function is just used as an expression, which is then immediately invoked. Very confusing. Okay, let's just play around with this a little bit just to get a sense. Don't worry about the immediate, all this nonsense. You'll probably come back to that later. Let's declare a function. It's called increment. We can say increment 3, we get 4. Increment 5, we get 6. We can do increment 6, we get 8. We can do like a whole chain of increments. We can say a whole lot of these, and then, oh man, 7 times probably 14 closes. We get 23, which is 14 plus 9. So every time you run increment, whatever's inside that is going to be passed in as the value. And what happens if you do this is you say, well, I have 9, it gets passed to here. So it starts here and says, I need to know what's being passed to here. Well, it doesn't know what's being passed to here until it goes all the way through to each one and says, what's being passed to you, what's being passed to you, until it finally gets to something that's a 9. And it says, okay, this one's a value. You can actually run increment. It runs that one. And then it says, okay, now I know what's in here. It runs this one, and so on. So it runs them all backwards, basically. Okay, that's just a little fun. Let's skip. Let's do this tomorrow. Value versus reference, because I want to get to the demo. This is a tricky thing to watch out for with objects and const and changing objects. They're tricky. Okay, functions. We just talked about them. They're very important. They can be passed as arguments into other functions. They can be returned from other functions. And they can be anonymous. They can be assigned to nothing and just poof into thin air and then they're gone. So this is a common way, you know, you pass a function into a special function called map. And this tells this special function what to do in a different situation. So it's going to be running your function, but you've passed the function to the function. Very confusing. Here's another function which returns a function. This one, I want a factory which will make me some functions, so I can return functions from the function. Again, very confusing. Don't worry about it yet. Okay, we're going to do one more thing, and then we're not going to need any of that weird function stuff. We're just going to use regular functions. A block of code, you hand it something, every time you hand it something, it's going to run the parts that are inside it, and then at the end, it's going to give you back the result of all of that. That's what we're going to use for today. We also need to know about if statements and else statements. This is not nearly as confusing. If there's an if statement and you pass it something which evaluates to true, it's going to run whatever's inside it. If it doesn't, it's not going to run whatever's inside it. And in this case, because there's a thing called an else after it, so you can chain these together to say if something, else something else. So if this is true, this is going to run, and it's going to say the number is large. It's larger than 5, see? Else, it's going to say the number is small. And the number, by the way, is random because we're using that math module with all the fun things to get us just a random. You can just say, give me a random number. It gives you a random number from 0 to 1, a decimal, and then we multiply it by 10 to get 0 to 10 because who cares? I don't know why. So we do this. We should get, we're going to go back to running the program. So node index.js will run this new program. Every time we run this, we might get a different result because it's running this random thing. So that one's large, that one's large, that one's small, that one's large, and so on. And this lets us basically look at the values of things and take different paths. This is one of the things that is needed for a system to be Turing complete, to be able to compute anything that you want to compute. One of the things it has to be able to do is decide on 2 different paths based on like a value or a check, it's called. So in this case, this is a true or false. And this is an expression, which is a variable, which we've defined up here, a value, and an operator, which is going to take those 2 and combine them and produce a true or false. This is greater than, it's the same that you know from math. It does the same thing, except, you know, in this case, that's what it is, technically. It's an operator. It produces a Boolean. It takes 2 things on either side. Okay, so this is, does this make sense to everyone? Is this, any things that are confusing about this in particular? There's one more thing to add to this, and that is that you can chain as many together as you want. So there's a third thing you can do. If this one, then whatever's in here is going to run. If this evaluates to true, whatever's in here is going to run. Otherwise, it's going to start checking down the list. And else, if it gets to an else, it's going to say, okay, that's the one because it didn't do anything else. But if it has an else if, it's going to check against the second thing, right? And then it'll only continue if it is false, if that second thing is also false. So in this case, we're going to generate the number. We're going to first compare it with 7 to return true or false based on whether it's greater. If it's greater, then this is true. We will go into this and we'll print it's large. Otherwise, it will check the second thing. And that's going to do a similar comparison, except the value is 3. If it's true, then it's going to run what's in here. And it'll say medium. Otherwise, it's going to, this will run any other, whenever both of these are not true, it's going to run this. And it's only going to run one of them because we have, they're separated conditionals and they're all part of the same statement. So the idea is that it doesn't run this one and then check this. It runs this one and then it's done. That's the end. So it runs only one of any particular grouping of if, and then else if, and then else. But there can be as many else ifs as you want. You can check every number individually all the way down if you want and print different things. And it will only do one. Now there's a better way to do this if you have a whole lot of different things. And we'll look at that tomorrow, but we don't need it today. So I think let's do an activity in the last hour. Does that sound good? All right. Okay, so the activity is we're going to make a calculator. And we're going to do it in the same file. We're going to run it in the same way. And I will paste, this will all be, it will be put up on GitHub so you can see the reference after. So don't worry if you, but I would encourage you to try to type along because that will help. Okay, so this calculator, we're going to say this calculator takes some kind of input as a string. So this, pretend this is like if you had a calculator with buttons, and the buttons were like a keyboard, they're like a form on the web, and you're running some of these functions which will say, you know, get the value in that input. You've done this kind of thing. You actually get the value and you get it back as a string. So this is, we can then take this, if you want, tomorrow we could take this and put it into a web page and do exactly that. But right now let's just pretend somebody has already done that. They've typed all the things into that input and then they've clicked calculate. Now this is a calculator which works in a slightly weird way for the purposes of this lesson. If we were going to do a normal calculator with, you know, 5 plus 5 and parentheses and exponent, like it would be a lot weirder and complicated to build. But there's a very simple way to show arithmetic which is unambiguous. It'll be correct, and it's a little weird to humans, but it's a lot easier for computers. So we're going to do it that way. This is called reverse Polish notation or postfix notation. So a little background here. If you do 5 plus 5, this is what you're familiar with. This is what JavaScript is familiar with. This is an infix. It's called an infix notation. So when you're doing the operator and you're adding the stuff, the operator goes in the middle. The plus goes in between the two numbers, and it combines together the two on the either side. One of the problems with this is then you need parentheses sometimes because there's no way to like tell it the order in which, you know, what should you add or multiply first. You need to do this, and you need to do that, and so forth. But it's all stuff we're familiar with. The notation we're going to do is where you always give it two things to operate on, and then after those two things, you give it the operator to use. So this would be 5 plus. And some people might, I don't know if anyone is familiar with like calculators that do stuff like this, but some kinds of like accountants calculators or something works either this way or the backwards way where you do the operation at the end or the beginning. So this should work the same, but like let's compare the infix at the top here. We have 5 plus 5. This one we have the 2 5s and then the operator to do. If we want to do times 7 and we want to make this be 5 plus 5 and then make that, evaluate that one 10 and then times 7. So 7 multiplied by the result of adding rather than 5 plus the result of multiplying. We have to put the parentheses around here to say these are grouped. I think, so there's a simpler way to do that in this notation, and that is to put the 7 at the very beginning and to put a exactly like that. So this is very confusing for a human to read compared to the above, but this is unambiguous and you don't need parentheses. What the computer does is it's going to say, well, I need to combine together any groupings like this with the operator at the end that I can. So this can all combine. This can't because there's too many and there's two operators and such. So it's going to combine these three first. It's going to get the result of that, and then only then it's going to combine it with this. So by doing the placement and putting, essentially nesting certain groups inside of other groups, you have an unambiguous way to show the order of operation.
So just to say that another way, when you say it's going to combine these three first, it's going to say 7 plus 5 plus 5?
No, it's going to say just 5 plus 5. So the thing about this notation, it only ever can work on two values and one operator.
Okay, all right.
Yeah.
Okay.
So that's how you can leave the 7 alone, is because there's 3 here before the operator. It can't. Yeah. Sort of, but it doesn't start. So it actually can read left to right, and when it gets to the end, you'll get the result, and we'll do that right now. So let's say we want to turn this into a string. This is something somebody has typed into the computer. They put spaces between everything. This could be a 50. It doesn't, there could be 2 characters in a number, but everything that's like a thing has a space around it, right? So we're going to say const input equals that. And we're going to sort of maybe put this in a comment just as like a reminder of what we're actually trying to do. We have the input. Now we need to start basically parsing and then turning that input into some kind of result. So our little language, it's all well and good to say this is how it works, but we need this string to actually, something that actually takes this string and does something with it. So we have to write a program to do that. What we're going to do is first, this is a pretty easy language to parse. There's only like 2 kinds of things. There's numbers and operators, and there are only like 2 kinds of syntax. There's either something or a space, right? So it's like either operator or number or space. That's pretty much it. And every time we see a space, we know that like that's a different thing. So the first step here should be to basically separate out all the pieces here so that we end up with units that we can work on. We want a 7, we want a 5, we want a 5, we want the plus, and we want the multiplication. We're going to have to deal with all of those. So this is pretty easy to do. In JavaScript, you can do input.split, and you pass it a separator. So, and let me know if you don't get these nice little hints here. This was not the case a couple years ago. You're kind of lucky to be doing some of this now, because once you start writing your programs, this thing jumps in and says, oh, I know what split is. Here's what it is. It's the separator, and it's wonderful. It's definitely a good turn of events. And it'll tell you, by the way, what you can do. So see, this is a string, so you just put the dot at the end. So you say input dot, and all of these cubes here are functions that you can actually run. The bricks, I don't know what these are. They're cubes and bricks. Kind of weird, but bricks are like properties. They're like data. If this is an object, these are the data pieces inside. This is the name Luke Skywalker or the whatever. It has a property called length, and every string has a property called length. That'll be the number of characters in the string. Everything else here, though, is functions. You can run any of these things on any string because they're just built into the language. So you can compare the locale of a string with a foreign string, I guess. And yeah, a lot of them I don't know what they are. You can blink a string. What the heck? I don't know what that one does. But yeah, let's not even bother. The one we want is split. So we want to split this string up using the space character. So I'm going to make another string in here that we're passing to the split function, and the value of this is the character. It should be character or string that we want to search for inside our our input string, and then split every time we see that pattern. So this one's very simple. Every time we see a space, we want to split it up. We can check our progress here by adding a console log, and then we run it. Oh, whoops. So I've done something a little incorrect here. I haven't assigned the result of this to anything. So I've said split the input, but that doesn't actually do anything to the input, and that's actually good. You don't want it to mutate the input, especially because it's a constant, and you don't want it like changing out from under you. So we're going to want to say assign it to something new. We could make it a let and do input equals input and start changing input like that. But why don't we name every step of this so it's a little bit easier to follow? So let's call it separated input. And that will be the result of running the split. And we're going to log separated input instead. So now instead of seeing just the string printed back at us, we're going to see this. And if you remember from the other slide, this is how you type an array in JavaScript. So what we've gotten out of that is an array with 5 pieces in it, right? And each piece is just one of the actual things we're interested in. This is good news. This means we can start sort of iterating. The only reason we really need to do this is because the number could have 2 characters. So you can't just split every character and say characters. You need to know, which ones are numbers that are together. So you need to separate them by spaces. You need to know there's something which says this is one number and this is another number. That's really, yeah. Right.
Well, kind of. Actually, wait. So, like, say somebody put a phone number in, and they separate it with hyphens.
Yes.
You could, like, this would separate, you could put hyphen instead of space. And
Yeah.
You could separate the area code, the first 3, and the last 4.
Right. Yeah. If they put a dash in between the area code, they could, Yes, exactly. It's usable for any one character. You could use it to separate an entire string. Like if there was you could use it to separate like by a word. Like if you had a whole lot of speech transcribed and I keep saying you could split every statement I'm saying by saying right? And then it would split it into every time it sees that, it would say, I'll split here. And those don't turn into the final input. If you notice, there's no spaces at all in the final. So those just get pulled right out. And they're used to split the input. All right. I mean, go ahead or write it down or,
Well, I was just going to say, can you split it using an index position?
So that's a different function. Split is like match a thing. If you wanted to split on a particular position, you can do slice. So this one takes a number, and it doesn't it doesn't return an array of both of them. It only is going to return, I think, the part after this, the 5th position, which doesn't even exist. Let's see what happens. If we do slice 3, we're going to go to about here and slice off the rest, I think. So we'll get this. Yeah. So that's how you'd split at an index position. There's also splice, which is that one actually mutates the string. So yeah. Anyway, those are more. That's what you're talking about. And feel free to just poke around here. This is actually a really great way to learn some of the JavaScript conventions at your own pace. You just you get a variable. It could be anything. It could be a number, an object, whatever. Strings are really good to try. You put the dot at the end, and then it'll dump out this whole list of all the functions you can do. And as you highlight each one, so if you like, oh, I guess you got to do it with the keyboard. So as you highlight each one, if you put the dot, you get this thing, and then you start pressing down, you can scroll through them, and it'll show you a little manual for each one, which is really great. I mean, it's returns a bold HTML element, returns the character at the specified index, and these are the signatures. So position must be what this argument is. So this means you have to pass it one argument. The argument is typically called position, and it should be a number. And then after here, this is telling you what that function should give you back. So this should give you back a string. If we look at split, it's going to say we want a separator, which is a string or a regular expression. Don't worry about it. And then you can optionally, the question mark means it's optional, you can optionally add a limit of the, I guess probably the number of things that it can return split up. And the return type, so after this whole parentheses, this little thing says it's going to give you back an array of strings, which is exactly what it does. Oh, and there's one overload, which means you can run it in a different way. I don't even know how to navigate to that. Anyway, try that in VS Code. It's a really, I mean, it's world class. Like, there's really nothing like this, and it's a pretty recent thing for it to be this good. So you're very lucky in that sense. We have split. We have the log. It logs the array. We have all our characters. We can then continue to take each character in order and basically start calculating. So we're going to set up a for loop. Or no, we can do a while. No, okay, we can either do a for and pop characters off the front and actually change the string, like pull the characters out and shrink the string until it's got no length left. Or we can do a for loop and iterate until we're at the end of the string. I think we'll do the second way. So we're going to do for let I. I is normal name for an iterator. If you need more inside there, usually you use J, K, L sometimes. This just means this thing iterates. This thing counts from one to another. It's a little unwieldy, but this is the basic for loop. Sorry, I equals 0. We're going to want to initialize it at 0. We're going to want to check every time that it is not at the end of the string. So we do this by saying it's less than the length of the string. Or sorry, the array. It works the same. Arrays have lengths, strings have lengths. Strings are like arrays of characters. But we want to check that the I is less than the length of our thing, our array, sorry. And then we want to add one to I each time. And I realized I should have done the slide on for loops. They have 3 parts. We talked about this yesterday. It's in the slides. Refer to that, and we're going to go over the rest of these tomorrow. But this is going to loop through the entire array one at a time. So it's going to look at the 7 first, then the 5. But it doesn't do that yet. All we have right now is a 0, a 1, a 2, a 3. All we know is that we're counting to the size of the array. We don't have the actual contents of the array. So in order to do this, we're going to say, let's declare another value or variable. And let's call this one token. And token is a normal way to refer to, like, once you've parsed, which is what we did by splitting by space, we have a whole bunch of things which are just some language thing, some other language thing. We don't know what they are. Any of them can be called a token. So we're going to call this variable token. And this will be the separated input when you index it at the I. Does that make sense? So when we were looking at the array earlier, when you pass a 0 to here, you're looking at the first item in the array. When you pass a 1, it starts at 0 and it counts up to just before the length of the array. And when you dereference, or when you extract the value, refer to the value at that position in the array, we're going to get back the actual number that's in that position. So to test this, that we've got this theory is correct, let's remove this console log so we don't get confused, and let's add another one. Let's log our token. There was just another console log up here at 6, I think, or it was up here. Yeah, I just don't want to be printing out all the other stuff we were already sure about, you know. So, well, that looks pretty good. So this is console logging once each time, so they show up vertically like this, but they're showing up in the right order, and those are definitely the tokens that we're interested in. So I think this part is working. Token is
Why did yours go vertical?
because you're running this console log 5 times. Once on every time through the loop, you're going to run it separately, and every time you run console.log, it adds it on a new line. That's the way that it works. Yeah. Okay, so we have a bunch of tokens. We know they're pretty good. Now, what we want to do is start deciding what to do based on what the token is. So there's several things the token can be. It could be a plus symbol, which means it's add. It could be a star symbol, which means multiply. It could be a slash, which means divide. It could be a dash, which means minus. It could be a number, or it could be several digits together, like a big number. So those are all possibilities we're going to have to check for right here. First, I mean, I think what we should do is say, actually, yeah, we should create right now. This is sort of a spoiler. What we're going to need in order to do this is what's called a stack. So a stack is like a stack of paper. It's a structure that's commonly used in computers. It's how part of the V8 engine, JavaScript itself, works. There's a stack that's things are being placed on top of the stack, and then things are being taken off the stack. The idea of a stack is that you always get out the last thing you put on. And if you put more things on, then the things that you put on a while ago is sort of buried in the stack, and you won't get it until you pull off enough things to uncover it again. So a stack is it's what's called a first in, last out data structure. The first thing you put in is going to be the last thing that comes out. So we'll call this one, we'll just call it stack. And you can do a stack, you can just make it an array. And this array is going to basically hold all of the values that we're accumulating as we go through this computation, and we end up with the final result. And we do this in the following way. Every time we get a token, we have it here, we're going to check it against a whole bunch of possibilities. The first possibility is that it is a number. And then the easy way to check that it's a number is you can say if parse, and it immediately suggests here, we can parse float or we can parse int. We could actually do this with decimals right away. So why don't we just say parse float? So this will work with decimal numbers as well, as long as they're separated by spaces. So we're going to try to parse float this token. Let's do a little demonstration in Node. Parse float is a function. It's just a built-in, it's not in any module, it's just a built-in function. And when you pass it anything, it will try to parse it as a float. So you can pass it true. That's not a number. It's going to say not a number. You can pass it 5, the number 5, and it'll be like, that's already a number, but it's good enough. That's a number. You can pass it the string 5, and this is where it's important for us, because you can pass it the string 5, and it'll say, that's easy to convert into a number, so I'm going to give you back that number. Now you can also do, decimals, and it'll do just as well with those. Converting a string or anything that can be converted to a number. It's usually a string, yeah. Parse int is the other one. So this one, I think parse int will round this one. If I do parse int of 5.55, I get 5. And the same if I do the string 5.55, I think, it just chops out. It says, well, you're looking for an integer, and that's close enough, but I'm going to round it for you because have fun figuring out that, So, because it's just throwing away everything that's not a whole number. The way that computers by default round is down always. It's a floor function because they always are just like, well, don't need these, and when you just throw them away, you're left with the lower number. So yeah. Yep. I will confirm that, so I'm not telling you something wrong, but yeah. Okay.
Oh wait, are you parsing between the numbers and the operators? What are you parsing?
So we're using this. Actually, let's do this separately. Const try number, attempt at number equals this. We're going to try to parse it. And this thing, we're going to save it for later because we might want to use it if it is a number. But it's all we know right now is that it's an attempt at a number. It could be something else and it could not parse, right? So we save it for here. And what we're checking first is if it's not equal, so strictly not equal to that special not a number. And this is an easy way to say, is this thing a string representation of a number? If if you look at this, is there a way to convert this into a float, which either has or doesn't have decimals?
Okay, just so I'm clear, we're still just doing the function 5 plus 5 times 7, right?
Yes. But 5 plus 5 times 7.
Right.
Yes.
So I'm not clear on why we need to make sure it's a number or parse.
Because it could be the times symbol. It could be the plus symbol.
That's what I meant before. Okay.
So we're actually doing the entire calculation in like a level inside JavaScript. We're not just letting JavaScript do it. We're actually making our own little mini language for calculating and then parsing that with JavaScript. It's a little... Okay. So, attempt at number, that could be not a number. But it could, if it's not a number, then that means it is a number. So this is like, okay, we know it's a number now, right? This is like, it's not a number. We tried to parse it, and it's not a number. We know it's a number. In this case, we're going to take our stack, and all we need to do with this is say we found another number, better keep it on the stack. Put it on the stack. That's it. So we're going to say stack dot, this is called push. So arrays have another method called push. And when you call this, you pass it any number of items. You can pass it, a whole group to push at once, but we're only doing one at a time. And it returns a number. Whatever. Oh, it returns the new length of the array. Okay, what do you do? It doesn't really matter what the length is, but we know we want to push it on top of the stack. And to be clear, this is still just an array. We're only using it as a stack really by using these conventional stack methods. So the conventional ways to operate on something as a stack is to say push and pop. Those are the words.
Can you move your cursor so that box disappears? So
This one? Oh,
No.
this box.
okay,
Okay.
it's gone now.
So we're going to do this. We're going to push, which means put it on top of the stack. Pop is the reverse. Take it off the stack and return it, because you might want to use it. But that's it. So when you use those two methods only, then your array basically becomes a stack, and it can be used in the way that you would use one. Okay. Now we're going to start using our control flow here with the else if.
Is add it to the stack and save it the same thing?
Yes. Sorry, save it on the stack. I didn't want it to scroll sideways because of the text size. Is that still big enough? Yeah. Okay. I don't like scrolling sideways. It's like a pet peeve. It's not fun to do. Although these trackpads are like the best way to scroll sideways ever. They're pretty great. Anyway, we know it's a number, we save it on the stack. That's the rule for numbers. All numbers, drop them on the stack. Now, we need to look at all the other operators because there are, I just realized I'm running very low on power. I might have to run for a power cord in a couple minutes. It's not USB-C, it's older. This one, John, you won't mind. I can borrow that, yeah. Okay. So, otherwise, the other option, let's just go through the other options. There's no easy way to say is a plus in JavaScript, so we just have to say attempt at number. No, not attempt at number, because that's just going to be none if it's anything else. It's going to say this isn't a number. That's the whole point that we were doing here, was to turn it into either a number or none, so we could check. So we're done with attempt at number. And actually, let's get rid of that. Running this thing twice, it doesn't even matter. Sometimes it's like, oh, you don't want to run functions more than once because it's wasteful. But who cares? This is confusing name, and let's just say parse float here and parse float here, and we're good. Right? It's pretty clear what it's doing. We're going to try to parse it. If it's not a number, we're good. It's a number. Otherwise, we need to go back to the token and basically check against each of the other possible things it can be. The first thing that token could be is a plus, right? So if it's, yeah, thank you. Only, so the numbers, we've done that with all the numbers. So everything that, where this here is true, it's going to say, yes, this thing is not a number. That by logic means it is a number. The only thing you need to do with numbers in this scheme is put them onto the stack. Trust me, it'll work later.
So
Yeah.
That's what the push is for.
Yes, the push is to say we don't do anything with the number because there could be an operator coming up. We need to basically wait for the next, because we're going to wait for, when you do it the first time, it's the 7. You can't do anything with the 7 yet, so you need to put it all the way at the bottom of the stack, and then keep looking for more numbers and operators.
You do realize that when you delete things quickly like that, that we have to, well, I have to look through my code to try to figure out what you took out, and that takes a minute.
Okay.
Now what I have on my screen doesn't match what you have.
Okay.
So
Let's undo it and then redo it very slowly. Thank
you
you.
don't have to go.
Well, thank you. I mean, no, I much prefer you to say something rather than it to be just, yeah. Okay. So you so converted this. You said this is a bad idea. Don't use this name. Yes. And I'm just replacing it with what its value is. Yeah, sorry for the spastic.
I'll go back to the videos. I'm just frustrated right now.
Okay. Well, so we pasted in two places. That was something of a mistake to do it in the first place and then undo it. So like that. But does this? Is everyone make? Does this make sense? Okay, no problem. I think we need. We need some music in the stream for all the internet people. There's no, it's not there yet because we're gonna add it back again.
So this is
Yeah.
going back to like the video of Richard Feynman.
Yeah. Yeah. Yep.
This is because computers are so dumb that they don't know it's a number or a symbol. Is that what you're saying? It has to figure that out first.
Kind of. I mean, this is several levels still, but I mean, we're like levels on levels on levels. There's the computer level, there's the browser level, there's the JavaScript engine level, there's our JavaScript program level, and then there's our special language inside the Java. Like there's so many sort of layers of abstraction between this and an actual computer. You can have languages that are much smarter in a sense. And that's what JavaScript is in effect, is it's a lot of stuff built on top, and we're just adding one more. So it's very far removed from, but this is kind of suggestive of why it, at the very simple levels, it has to be so verbose and weird, is because the only simple way to describe how to do arithmetic is with this weird sort of backwards notation. And it's very, like, we're actually probably going to finish this on time, even though it's like we'll do all the arithmetic and it would take a lot longer to do in any other way. It takes not very long to do here. We're like halfway or more done with this, which is kind of weird because all we've done is drop the numbers over here so far. But if we do the next case, which we had, is otherwise if the token equals is exactly equal to the plus sign. So the next possibility is if it's a plus. And we want to do a special thing for plus. we want to say, we'll make an A, which is our first value. So if it's a plus, we kind of know there should be at least two things on the stack. You shouldn't have a plus right at the beginning, because it's not. It has to be after at least two things to mean anything in this language. So we're going to want to pop two things right off the stack. We know those are the things that it should operate on. And we know that they're numbers because we're only putting numbers on the stack. So this starts to make sense. Like, you know that whatever's already been put on the stack has already been processed enough to make it a number. So we're going to say A equals stack.pop. We'll pop the first thing off. Then we're going to say B equals stack.pop. And then we're going to say stack.push A plus B. So this is the plus. This is because this is the plus character. So we're actually going to do the plus here. And it's very silly because JavaScript is like, I know it knows what a plus is. You don't have to do any of this. But this is our language. So if it's a plus, we pop the two things that are most recent. We know they're numbers. We add them together. It's a number. We put it back. That's it. We can pretty much copy this whole thing like 3 more times. And all we're doing differently is checking for the other operators. So paste again for times and divide. So we have plus, the second one is minus. And here we're going to push the result of the real minus. Here we're going to say times, and do the real times. And here we're going to look for the divide character, and we're going to pop the two things, and the thing we're doing with them is dividing. But then we immediately push those two values right back onto the stack in all of these cases, because there could be more operators later, and we need to be able to do the exact same thing every time. Yeah, so here. Yeah, and we could do one for like the power exponent maybe. Why don't we do one for the exponent too?
But, I'm sorry.
Yeah.
It's not clear to me why we're doing the divide or subtraction, since
It's
that's not part of
not part of this equation, but we
So you're
want this
showing-
calculator to work with anything, even if it has times or divide.
Okay.
Or the caret, we'll say the little caret means power to the power of x to the power of y. So we can do that pretty much just as easily. We paste one more time at the end, and we say if the token is the caret, then we're going to, instead of any of these simple, remember there's no simple power operator literally in JavaScript. We're going to have to do something different. So in this case, we actually will run math.pow and pass it A and B, because that's how you actually do a power in JavaScript and get the result. But in our language, you can just do the little caret, and that will mean to the power of. But, of course, it has to go after both numbers. So it will be like 6, 2, caret. That means 6 to the power of 2. Okay, now let's say that's it. That's the whole language. Is these numbers and then these 5 characters. We can say anything else is invalid. Like, that means you type something wrong. It's not going to compute. It doesn't know what to do with it. So we'll put an else at the very end, and we'll say throw error. This is a way to say just like, it's broken, you know, this is not working. Invalid, sorry, I'm doing double quotes now for some reason. Let's go with it. Invalid input. Oh, sorry, with JavaScript you want to do throw new error for some reason. Okay, so that's pretty much our whole calculator. All that's left to do is once we're all done doing these operations, we should have one number because it should have combined everything together. And if you entered your equation right or whatever, it will have the right number so that every operator has two things to work on, even if those two things are the result of a previous operator working on two things. But if not, then it's also invalid. So we do if stack.length is greater than 1, we're going to copy this. So throw new error. It's still an invalid input in this case. Okay. By this point, the stack should only have the final value. Sorry, so I need to get used to this. I won't scroll it. Okay. Finally, if that's not true, that means the stack is either 1 or 0 long. It's probably not 0. Let's just assume it's not 0 for today. So this means we're good. So we return, or console.log, I guess, the result. Stack index of 0 is the first item in the stack. And because we've been pushing back the results every time we do a calculation, we should have pushed right to the beginning. The first item on the stack should end up being the result of the last time we push something, because there should be nothing left in the stack. We should just push that result, and that's the end. That means you've gone through the whole thing and compressed it all down by combining everything until there's only one. And I don't know if this is going to work, but let's see again. Our input here is 5, 5 plus, so that means 5 plus 5, which means 10, and then it's 7, whatever that is, times, and that is 70. So we should see it print 70. If I'm very lucky, it will print 70. No, it crashes. This is the normal way of doing things. Okay, so this is actually a little helpful. You're going to get much more into debugging and errors, but right in the console, when you see an error, this is going to show you where it is. So it's on line 40, colon 40. It means we threw an error right here. Now maybe these should have different messages so you can tell what the problem is, but at least we know the line, and it's because the stack length is greater than 1. Let's figure out what is in the stack by just console logging it anyway before we throw the error. And let's log the whole stack so we can see what's wrong. Sorry. Okay, if we scroll up above this, we see we have 7, 5. Well, that's a little bit interesting because that should not have happened. Because we should have, we should go through this. We have our token. The first 3 times it's 7, 5, and 5. Each of those should be pushed, so the stack should have 7, 5, and 5. No, because when we get to any operator, we're always operating on only 2 items at a time. So once we get to here, we should see the token equals a plus. We should pop the previous 2, which are 7 and 5, and then we should, is it because I'm declaring this const and it shouldn't be? Maybe we should declare them up here and remove all those consts. And you can declare something without telling JavaScript what it is by just declaring it without an equals. You don't assign anything to it. So we'll let 2 mutable variables A and B, and then because we've already declared them, we can remove all the consts here and just reuse them. And I don't know if this is what would be causing the error, actually.
So we're taking out all the stack pops?
No, we're taking out just the const keywords
Oh.
because we're declaring A and B. So A and B are declared at the top here, and then everywhere we were using consts below. And it's still broken. Okay. Oh, wait a minute. I think our loop is ending a little bit too early. Yeah. Oh, yeah, okay. This is silly. It has nothing to do with the const. I'm sorry for another weird change. But the problem is that we only should be for looping here and doing this stuff. Our loop, this should be after the loop's all done. We should be waiting for all of the stuff to loop through and do all the popping and pushing and everything. And then at the very end, we should be checking for the final value. So I'm going to remove or unindent this by doing a shift tab, delete that one, and then add one up here. So that's kind of a silly mistake. But does that make sense? Or
No.
okay.
Okay, so.
I-
Just the brackets?
And yeah, this will be up on GitHub in about 15 minutes. I'll send you the link. Yeah, it's
Yeah, I'm following along with you as far as what you're removing and what you're adding. I guess I just need to see the end result to pull it all together.
it doesn't make a whole lot of intuitive sense. This is a pretty, and clearly I'm messing it up too because we have 7, 5, 5, not a number, and not a number. And then we get an error. Huh. So we are not, oh, okay. So here's the problem. In this case, we're parsing the float again. In this case, we're just pushing A plus B, even if A and B are strings, or timesing. And that's the problem, because if you try to time some strings, it's not a number. So instead of doing this, we need to wrap every one of these, sorry folks, with a parse float. Every single time we pop a number, we have to make sure that it's already a float. I'm going to paste this half first, and then go back for the other half. Now it'll highlight with the red everywhere you need the other half of the parentheses. And we're kind of out of time, so if this doesn't work, I have to give up. Get back at it tomorrow. It's a programming lesson. Yeah.
This part of it can already, the kinks be worked out before, so that way we're not trying to like figure out, because just trying to follow along with it and then having to go back and try to refigure it once things are corrected. During class it's not helping
Okay.
me at all. I don't know about anybody else, but I'm thinking like if maybe the kinks were worked out, so that way we can just follow along with solid code.
Mhm.
Yeah, because this is making it a lot more confusing for a subject matter that's not easy to begin with.
All right. Well, the demo, you are totally right. The demo is a failure, and it doesn't even run. So, yeah, that's well.
It's not an utter failure, but it, for a subject matter that like I have like I have some experience with JavaScript, not a whole lot, and it would, I don't know if anybody else agrees with me. I think just for the kinks to be worked out before we actually try to learn it would be helpful. Am I the only one who feels that way?
No, I mean, definitely makes it a little more confusing.
Yeah.
Yeah.
I like seeing the process of seeing what works and
Right,
doesn't work.
right. But we have time to learn process once we get a foundation. Some of us don't have a foundation at this point. All of us came into this at different levels.
Yeah, and that's what's hard. So you're
Right.
speaking, you can't. It's hard to speak for everyone.
Right.
Mhm.
I think just do what you're doing, always seeing what will be best for you, and hope that we all can
Well,
work with
that's why I'm asking, because I don't, if it's just me, then I can go home and do stuff for just me. But if there are others that, feel like the foundational stuff, without the kinks, is going to help us to move forward. That's why I was just kind of putting it out there.
Yeah, I should not have tried to do this one from memory, because it's very confusing, like you're saying. There will be a fixed version. It will work. It'll be up on GitHub, and that will be tonight. The homework is to there's a video homework, but the extra credit homework is to reverse it so everything goes the other way. But I don't know if anyone's going to do that. Yeah. Um,
You scroll your code. Just gotta put it out there. I've been using Rhinestone. Like if anybody wants to, like, I mean, because reading also helps a little bit. So Rhinestone has like everything, like it explains everything, and you can play around. They have like little exercises for you to test out. Rhinestone for JavaScript. Yeah. Huh?
Is it a video? It's a book?
Yeah. So this is yeah. It's like a textbook.
Is it like a book or is it something you can access online or?
You can access. It's online. It's like an online textbook.
Okay. Thank you.
She's gonna put it in chat.
Oh.
Go over here.
This is what I did in class with me.
I have a bunch of errors in mine that I something
yeah, I'm not sure. I'm trying to log, like the stack is just growing. There's nothing being popped from the stack. It's never shrinking. see.
Two lines of code, one line of code.
So the problem is it's saying everything is not a number every single time. No, I don't. I'm gonna be trying to fix it.
Can't find like this just right up here. Why?
Yeah. Because you're missing a open bracket right there. Up at the top. See, next to the when you do if parse float. But so see this one, this line needs one at the end of it as well, just like the for.
Duh! I knew it was just this
Oh, other way.
an open bracket.
Open, yeah.
Dummy.
So,
Wait.
and then you got to go over and delete it. This tries to be
It's
helpful.
closed,
Like,
yeah,
oh,
I
you
know.
want brackets, yeah. So and then
nice.
it draws the line to show you that it
There you
goes all
go.
the way until there. Yeah. And
Where
that's-
was that again? It's 7 and 9.
Yes.
Thank you.
Yep. Okay. It thinks everything is not a number. Why is that?
No, my boyfriend's a Red Sox fan and I'm a Yankees fan. Oh. He's like, listen. He tell me this. This is dead and this is one. I mean, this is 8-0 Yankees. Yeah, exactly. So my phone.
So do you know what the story is here? We're going to go into this next month. I got totally crushed by one of the bad things in JavaScript. Not a number is one of the only things that is not equal to itself.
Really?
It's not equal to itself.
Yeah, I'm like, why?
So there's a special thing. Yeah, there's a special thing you have to do called is not a number. And you can't check like we were checking. You have to check is not a number.
I mean, we haven't been doing amazing this year either, but it's really good, but it's gonna give you a lot of virus.
No, it's this. It's yep.
It's a 50. I can make it.
So I was just logging to try to figure out what's going on, but you have to run a special function called is not a number. Returns a Boolean value that indicates whether a value is the reserved value, not a number, which is not equal to itself.
Show me how you did that.
Well, since not a number is so many different things,
I mean,
it
I
can't
guess,
tell the
yeah,
difference between
yeah,
the different kinds of dot numbers.
yeah. So
Again. So down here it says.
yes,
So I know it's a 35. What's the 2? Go back to 2.
that's character 2. So it's seeing the E there, and it's saying, like, I didn't expect another else. So the problem is you have 2 else's in a row. There can only be one else, everything else, you know.
So this just needs to go along with its.
So I think we need to fix quite a bit. Do you want to? How late are you staying today?
Not late. We're going. My brad's going.
Okay.
We're going. But I'll play with it tonight.
So I'm gonna post this
Cool.
working one. Which
I want to try to
it'll totally
find it
work
on my
now.
own. Do you know what I mean? But thank you.
There it is. It works. No, everyone's
Woohoo!
already gone.
Woohoo!
It's
It
too
worked.
late.
No, it's not.
Yeah.
Stop.
It totally works, and I just got really crushed here by this thing. No, I mean by this JavaScript thing. It's yeah. I hope. Anyway, this will work with anything now. So you can do. No. Stream. Okay. Thanks everyone. See you later.